Hello, I'm Chuck Thompson. You're about to see the video on some of the abilities of the memorist Rajan Mahadevan. I led the research team that investigated Rajan's amazing memory. After you've seen this video, some of you may want to learn a bit more about his abilities, and if you do, go to your library and they ought to have this book, which is entitled Memory Search by a Memorist. It was published by Erlbaum in 1993 and should be available in your library. But right now, let me introduce you to the graduate student who was perhaps one of the most important member of our team. In addition to helping us determine what studies we should do with Rajan, he coordinated the efforts of all the people who worked on this project. Rod?
Hi, I'm Rod Vogel. 8 undergraduates worked with us during the project. Danny Ashleyman, Manita Dowdy, Grant Nurnberg, and Tricia Horde served as our 4 control subjects. David Welch, Jana Ortez, Will Eccles, and Cosima Hadidi did most of the testing, but Thad had the informal assignment of keeping us in a good mood.
Hi, I'm Thad Cowan. You probably all know that Rajan made the Guinness Book of Records by reciting something more than 30,000 digits of pi. And Chuck, our team leader, wanted to call the title of the book A Slice of Rajan's Pie, but cooler heads prevailed. Now I'm going to introduce you to Jerry Freeman, who in turn will introduce you to a world-class memorist, Rajan.
Hello, I'm Jerry Freeman in the Department of Psychology, and this is Rajan Mahadevan, who's a graduate student in our program. I've had the honor and pleasure of working with Rajan for the last couple of years on a grant which is funded by the National Institute for Health to study Rajan's memory. Rajan is one of the few people in the world who has mastered enormous amounts of information which he keeps in memory, and our grant has been to study his memory abilities. Rajan came to us as a graduate student and told us that he had been in the Guinness Book of World Records. In July of 1981, Rajan correctly recited the first 31,811 digits of pi. He remained in the Guinness Book of World Records for 7 years until his record was finally eclipsed in 1987 by someone who recited the first 40,000 digits. Rajan's recitation of pi is incredible, and it is unique because he recited all of those digits in 2 hours and 47 minutes. The person who surpassed him with 40,000 digits took over 17 hours to make that recitation. Our project for the last few years has been to study Rajan and to try to understand how it is that he has this material organized in memory and how he learns material as rapidly as he does. Rajan studied pi from sheets that look like this. This is the first 5,000 digits of pi, and you can see that it is organized so there are 5 blocks of numbers. Each of those blocks has 10 rows of numbers in them, and each of those rows has 100 digits, each of them organized into sets of 10. Rajan studied 7 such sheets on his way to setting that record in 1981. Rajan, why don't you recite the first row for us of pi, the first 100 digits.
The ratio of the circumference of a circle to its diameter, commonly denoted by pi, is approximately equal to 3.14159 2653589793238462643383279 502841971699350582097494945923078164 062862089986280348253421170679.
By the way, although the sheet is sitting between us, Rajan cannot see it because of the barrier, and we've asked him to look into the camera so that when he recites, so that she can see he is not glancing down. Rajan has these organized in a rather interesting way, and unlike, and to the point that he can go to any place in this set and retrieve digits. Unlike most of us, when we organize or learn large blocks of information, we tend to learn it in a way that if we want to recite it, we have to go back to the beginning. He doesn't have to do that. To give you an example, if I ask you to think about the Pledge of Allegiance to our flag, what is the word after nation? You would say, perhaps you've got indivisible. But if you ask yourself how you did that, you did it by going back, starting at the beginning and working your way through. He doesn't have to do that. Rajan can pick up at any point in this set and begin. And so let's do a couple of demonstrations. First, Rajan, let me ask you to give us the 39th row.
180937734 4030707469 211201930 20330380197621101100449293215160842448859 9637669838952286848 312355268.
Correct, as usual. Clearly, in order to get to that point that rapidly, he couldn't have been starting at the beginning and working his way through. He can also get to any particular location in pi. So, for instance, Rajan, let me ask you, can you tell me what the 4,552nd digit is? That's correct. Okay. And another, how about the 3,817th digit?
7.
That's correct. Okay. Can you tell us how you did that?
Well, actually, I memorized the digits by rows. I memorized the digit, any numerical material, I memorize the material in terms of one digit at a time. I do not group or, chunk information. In other words, I don't use mnemonics or memory tricks or memory systems to memorize digits. I memorize the digits one digit at a time and by rows from left to right. And the reason why I do that is that's the way we traditionally learn to read. I traditionally learned to read, verbal material. I know to understand it's the other way around in certain languages like in Arabic or Yiddish, but in my own native tongue we'll read verbal material from left to right. So I memorize digits one at a time and in rows starting from the left to the right. And in the case of pi, what I did was I put markers after every 10 digits. The reason I did that is I find it very convenient to memorize digits in exactly the way the digits are organized on the learning material. In the case of the digits of pi, you'll see that the decimals or the digits have been grouped in strings of 10. So I find it very convenient to put markers after that, after every 10 digits, so that whenever I reproduce the material to myself, in order to test myself, I'd make sure that I would be exactly at the right location. So grouping the digits in terms of, or putting markers after every 10th decimal place served as helped me to monitor my own recitation. And it helped me when I practiced, for setting the world record. So it's as though each group of 10 digits as it is on the sheet of paper is like a word. So in other words, if you give me a group of 10 digits as it is organized on the sheet of paper, I'll be able to tell you what the next 10 digits are. But on the other hand, if you give me 10 digits where, say, you have 5 digits from one group of 10 and say it overlaps and you get 5 digits from the next group of 10, then those 10 digits do not constitute a quote word. So I'll have a lot of difficulty, telling you what comes after that. Great. So to reiterate, digits I memorize digits one at a time. I memorize digits by rows. And in case of the value of pi, I sort of, you know, put markers after every 10 digits mentally, because that's the way it is in the sheet of paper. And also, I always take a good look at close look at the first column digits. And the reason why I do that is each digit or set of digits in a column helps me to serves as a cue for me to recall that particular row. So that way I make sure that, you know, I give the first row, second row, third row, and say I won't skip the fourth row, you know. But if I don't take a close look at the first column, I may have a tendency to skip a row by accident.
Rajan's performance mirrors exactly what he says, and certainly in our tests we confirm a lot of this. As Rajan noted, he seems to have the information organized in these sets of 10, and so let's do a little demonstration to show that. I'm going to read off to you 10 digits, starting at the beginning of one of these sets, and you give me the next 10.
Okay.
Okay? And I will just pick this at random out of here. 6369807426.
54252788625.
Correct. Let's do another one. 40525711459.
I know it's in the 42nd row, in the 32nd row.
That's right.
10289700641.
That's correct. That's correct. This task is a lot harder, however, if we start in the middle of one of these sets and overlap to the next. So I'm now going to start somewhere in the middle of one and try to read 10 consecutive digits and see how long it takes. This is a very difficult task. And so, Rajan, if we get past 30 seconds, we may want to stop you. But let's see how you do.
Okay.
All right? Let me pick up set. 8818347977.
896091.
No.
Okay.
Okay. Shall I read them?
Okay. I think you read them too fast. Maybe.
All right. 7535663.
Okay.
Okay. All right. Let's pick another one. Okay, Rajan, I'm going to pick now a set that starts in the middle of. Rajan, I'm going to pick something that starts in the middle of a set, and you now pick up with it. 691663548.
Oh, could you read them again, please?
I'm not sure where I started. 616635488.
62305.
That's correct.
Well, that was just a lucky guess.
It was a very good guess. Very good guess.
But yes, the point is that it's a lot harder because it's like giving me 10 digits that is a, quote, non-word. So you pick a bunch of, say, you take two words, constitution and say emancipation or whatever, and then start reading from Tutioneeman or whatever. You overlap between those two words and ask what follows. It's a little harder.
Right. In some of our laboratory studies, we've been able to demonstrate that it is in the first few digits of those sets of 10 that most of the information that allows them to identify them lies. If we take 10 digits out of here, one of these 10-digit sets, and we take away one of the digits in the first, second, or third position, Rajan has great difficulty identifying it. If we take away something near the end of the set, sort of like at the end of a word, then it is much easier for him to do that. It's quite clear to us that Rajan does not have a photographic memory, although there are times when it looks as if he does. And one of the ways we can demonstrate that is to use new material instead of material that he has highly learned, like these digits of pi. And so we're going to do a demonstration now where we'll have a matrix of 49 numbers. This is 7 rows with 7 digits each that we're going to give Rajan to learn. We've asked someone in the studio here to generate such a list, and so now, please give it to me. Neither I nor Rajan has ever seen this matrix of numbers. And we'll give it to him to memorize, and I will keep track of how long it takes him to do so. Are you ready?
Ready.
This particular task is one that was first used by Alfred Binet, the famous French psychologist who is best known for his pioneer work with intelligence tests. Binet, in 1892, was commissioned to study a number of people who were called mental calculators. These were people who were very good with digits. And so Binet invented the matrix task as a way to study how they learn. Interestingly enough, Rajan's performance on this task is better than Binet's subjects, although clearly there are other people who have been recorded to learn this type of set faster than Rajan. His time for learning is very close to the fastest that are recorded. As you can see, Rajan is not affected by the fact that we're talking while he's studying.
Okay.
Okay, terrific. That may seem like a long time, but Rajan memorized that matrix in 1 minute and 48 seconds. That means that it took him a total of, you have to help me with this, how many seconds?
108.
108 seconds to learn 49 digits. That's a little more than 2 seconds.
2.212.
Say that again?
2.212.
2 seconds per digit. That's a truly remarkable speed. And so now, again, he will not be able to see this as I put it down for you. But Rajan, we're going to ask you to recite this matrix, and then I'll ask you some specific questions about it.
Okay.
Go ahead, whenever you're ready.
7627824 9459366 28345010267114392568719473723812196.
Very good, terrific. Now, Rajan, I'm going to ask you to recite for us the 5th row.
3925687.
Very good. And now, give us the 6th column.
2 6 0 1 8 7 9.
Good. And can you give us the main diagonal going from upper left to lower right?
7 4 3 7 6 7 6.
Very good. And finally, why don't you give us the first column?
7920313.
Barely got it out. It's quite clear that Rajan does not have a photographic memory. If he did, then the speed with which he recited any row, any column, any diagonal, if we wanted, we can even ask him to do this backwards, would be the same. He must have this organized in a very special way. Rajan, why don't you tell us again how you went about memorizing this matrix?
I memorized the digits, as I said earlier, one digit at a time, and by rows from left to right. So once I learn a row, and then I go on to the next row, again from left to right, and so on, until I learn all 7 rows. And I do not use mnemonics or any other memory tricks. I do not chunk or group the digits in any way, any meaningful way. I mean, that's part of mnemonics or memory systems. So I don't use mnemonics. I learn digits at 1 a second. I take that back. I learn digits one digit at a time, and by rows. And after I've learned every digit in every row, what I do is I take a good look at the first column. I learn the first column because every digit on column 1 serves as a cue for that particular row. So I make sure that I do not skip a row when I'm reciting the entire matrix. And like Jerry said, I do not have a photographic memory. The reason being that if I had a photographic memory, when he asked me for column 6, I should have been able to give that as fast as I was able to give back row 5, or whatever the question was. So it's as though each row is recorded on a separate tape. So if you ask me for row 5, I just have to pick the right tape and reel the digits off my memory. But if you ask me for column 5, it's like accessing specific information in a different tape. So if you ask me for column 5, or say whatever, Jerry asked me for column 6, what I have to do is I have to go to the first row, and then go through the entire row up to the 7th digit, and then skip back up one. That's the 6th digit, and then go up to the second row, and mentally, get started on the row, 2 or 3 digits, and then go right to the end of the row, and then back up 1, and so on. So it's clearly the organization is by rows, and I do not have a photographic memory.
It's quite clear that Rajan's memorizing of this new material is as he says, and many of our research studies certainly confirm that. It has been our pleasure to work with Rajan for the last few years, and I think it's fair to say, and you can see from his explanations and from these demonstrations, that Rajan has a rather remarkable ability. But there's nothing mysterious about how he does it, and he can describe for us very well how he does it. And again, we can show that that is in fact the case. If we want to have a metaphor to perhaps think about Rajan's ability, let me suggest the following. You and I could practice playing the violin from now till the end of time, and I suspect we would never be as good as Yitzhak Perlman. Or we could practice basketball for that long and never be as good as Michael Jordan. Similarly, with working with digits, we would probably never reach the performance levels that Rajan has, both in terms of the sheer amounts and also the speed with which he can do this. Like many people who are, in fact, have these rather remarkable abilities, Rajan also showed this from a very early age. Rajan, tell us about when you first learned of your unique ability.
At age 5, there was a party in my house, and we had some 20-some guests, and I memorized the license plate numbers of all the vehicles in the order they were parked. And that's when we got to know that I have a reasonably good memory with numbers.
Right. But that reasonably good memory of numbers manifests itself with a lot of practice. And like many people who are world-class performers, they combine both this unique ability and a heck of a lot of practice to reach the level at which they do.
Absolutely.
Rajan, thank you very much.
Thank you, Jerry.